This is the video notes, so it's going to go with guided notes for law of exponents. Now, these notes will be done in a 4-part series because we will take 4 days to do this in class. Okay, so here is part 1 today. We're going to look at basic vocabulary, zero exponents, and products of powers. Okay, so let's just go back really quickly to our vocabulary. Everybody knows what an exponent is, okay? Sometimes they're called powers, okay? So right here in A to the M power is how I would say that, A to the M power, okay? M is my exponent. But a lot of people don't realize that the A, the number or variable that has the exponent, is actually called the base. Okay, so that's the only two vocabulary words that we need to know. Base is the number or variable that has an exponent, and of course, M or the exponent is the power that is in your expression. Okay, now the first law we're going to learn is so super simple. It's called zero exponents, okay? Anything, I'm sorry, let me back up a second. Normally when they're talking about the laws of exponents, they're always going to use A as the base, and it is a lowercase a, okay? So here, A to the 0 means any letter, variable, number, fractions, decimals, whatever. Anything raised to a 0 power is 1. Now, a lot of people go, that's got to be 0. Okay, well, let's just grab our calculator right here. What if I put 5 to the 0 power? Can we see this? 5 to the 0 power, I get 1. What if I do a decimal? 0.36. I just grab a decimal to the 0 power. I get 1. What if I put in a fraction? Let's put in a fraction. How about, I don't know, 4/7? Okay. And let's raise that fraction to the 0 power. I give 1. It doesn't matter what it is. If it's to the 0 power, it is 1. Now, go ahead and scratch your head with that one. When you get to pre-calculus and calculus in high school, you will learn then why it is 1. Okay? Now, so let's look at our example. Example 1 says 3 to the 0 power. Well, that's 1. Even variables, because remember, variables represent numbers. Okay, so even a variable to the 0 power is 1. Now, let's look at example 3, and I'm going to slow down here for 3 and 4. Example 3, because the 0 is outside the parentheses, it means you're raising everything inside of the parentheses to the 0 power. Everything in the parentheses is to the 0 power. Well, any and everything to the 0 power we know is what? 1. Okay. Now, example 4 though is different. Look at example 4. What do you notice is different about it from example 3? Well, here's the catch. Because there is no parentheses, that 0 power only goes with the x. The 0 power only goes with the x because exponents only belong to what is directly in front of them. Over here, the 0 had the parentheses directly in front of it. So that meant it's belonging to everything inside the parentheses. So what I have here is different. The 2 has nothing to do with that 0 power. Now, don't you think about this for just a second. That's 2 times x, right? 2 times x to 0 power. So what that means is I'm going to keep that 2, but now my x to the 0 power is really 1, which means then that whole expression actually comes out to be 2. Remember, the 0 power only belongs with the x. So what I highlighted right here, x to the 0 power is 1. But I'm multiplying that by 2. So 1 times 2 is 2. Okay? Now pause right here if you need to and copy this down. And then we'll go to our second law of exponents. Now, our second law of exponents is called product of powers. Now we know the word product means to multiply. What do I know is right here? Now I have a to the m, a to the n. The way you would read this is a to the m power times a to the n power. Okay, we have a here and a here. Now they have exponents, but we know that in between those two terms is a multiply. Okay, is a multiply. Okay, now our law of exponents, remember, is just a way to shortcut doing work a long way. Okay, the laws of exponents are just a shortcut to having to do a lot of work. Okay, so what the law says is a to the m power times a to the n power equals a to the m plus n power. Now, what does that really mean for us? Okay, what does it really mean? Well, let's take a look at that. I'm going to pull me out a little cheat sheet right here. And let's write this down. Now, again, I'm pulling a little cheat sheet, so this just means focus. Okay? Watch, listen, digest. Do not write. If I have x to the 4th power times x to the 3rd power, I'm being told I got to multiply these x's together. Well, dang, we don't know how to do that, do we? We don't. But I want you to think about something. What does x to the 4th power mean? It means x times x times x times x. Right there. That's what x to the 4th power means. Now, what does x to the 3rd power really mean for us? X times x times x. We know that. Take 3 of them and multiply together. Okay? Now, I also have this right here in the middle. Bring down that times. Now, kind of squeezing all of that together. This is similar to combining like terms. How many x's am I multiplying together? 1, 2, 3, 4, 5, 6, 7. That means that's the same thing as x to the 7th power. Okay, so I want you to go back, a couple thousand years. People are beginning to understand the idea of exponents back during the days of ancient Greece. And this was kind of what they were having to do. They were having to write all of this out. And some smarty pants said, well, you know what? I see a shortcut. I see a shortcut. What if I just said, I've got 4 x's over here, and I'm going to put with it 3 x's over here. That gives me a total of 7 x's. And they said, well, dang, why don't I just do this? 4 plus 3. The 4 over here plus the 3 over there gives me a total of 7 that I'm multiplying together. And they said, oh, well, let's just try that again. What if I had x to the third times x to the second? Well, let's see if that works again. X to the third is x times x times x. X to the second is x times x. But what am I going to bring right down here in between them? Another multiply. Well, how many do I have? 1, 2, 3, 4, 5. X to the fifth. Well, bless. What's 3 plus 2? 5. X to the third times x to the second is x to the fifth. So what's really happening is we can't really multiply those variables together, but we're kind of combining the like terms, using those words loosely. We're combining those like terms to tell the person or the reader of your work how many x's you're multiplying all together. So instead of having to write 2 different x's, I can consolidate and write one x term. Okay? Now, let's just look at example 5 right here. We just did that, didn't we? Look right here. What did we just do? Same example. So now I want to show the work, and y'all, I don't want to show all of this. I don't want to. Ugh, yeah. Okay, so we're going to work smarter, not harder. So what we're going to do is we're going to show our law of exponents. So I'm going to write my 1 base x, and I'm going to show, just like right here in my law, adding them together. So 2 plus 3, and that's going to give me x to the fifth. Now, if you show your work just like that, you have shown level 5 quality work. I'm fixing my light, y'all. You hear me moving around. There we go. Now, we can do the same thing with bases. Okay? So look at number 6. Oh, this is a really good SAT type question. And actually, number 6 is something that all 8th grade math students have to learn. Okay? It says 2 to the 12th power times 2 to the 10th power. And somebody says, well, hold it. Why can't I just stick that into my calculator? Well, let me show you why you can't. Here's my calculator again. So let's do 2 to the 12th power times 2 to the 10th power. Oops. Go back and delete. Two to the 12th power. My fingers. 2 to the 12th power times 2 to the 10th power, so I get it put in the calculator correctly. Am I really going to want to multiply all those 2's out together to come up with 4,194,304? Nope. So here's a quick, easy way we can do this. I can say 2 to the 12th plus 10. Now, notice I kept my base. In both of these examples, the bases do not change. They do not change. Because some people's going to want to go 2 times 2 and make this a 4. Wrong. You keep your base and you add your exponents. So what this really is 2 to the 22nd power. Okay? Now let's step up the difficulty right here with number 7, because number 7, we're kind of going back to those variables because math 1 deals with the variables. 8th grade math only deal with number bases. So this is an 8th grade problem. These right here are the math 1 problems. Okay, so let's take a look at number 7. Okay. So number 7 has 2 different variables. We got A's and B's. Okay. These laws of exponents are just like combining like terms. You have to have the same basis. So what is going to happen here is I'm going to make sure I put the A's together, and I'm going to make sure I put the B's together. Okay, so a perfect way to show this work is I'm going to come right here and I'm going to put my A, and I'm going to show which exponents I'm going to add together, which is 3 plus 4. Then I've got my B, and I'm going to add those exponents. So I've got a 2 on that first one. By the way, what is the exponent on this B right here? Do y'all remember that if you don't see an exponent, we know it's a 1? Just like if a variable doesn't have a coefficient, it's 1. If a variable doesn't have an exponent, it's 1, okay? They're only going to tell you a number if it's something other than 1. So what I've got right here is 2 plus that 1, okay? This is showing the work to come up with your answer. So now my answer is going to be A to the 7th, B to the 3rd, and I'm done. Okay. Now, just getting a little bit step on this number 8. Okay. In number 8, we notice we have coefficients this time. I've added in the coefficient of -2 and +5. Okay, let's talk about the -2 and the +5 first. Those are not exponents. They are everyday, right on the line, coefficient numbers. If I ignore everything else in both parentheses, what I have is -2 times 5. And that is literally what I'm going to write right here. -2 times 5. Okay, they are not exponents. You do not treat them with the laws of exponents. You treat them just like plain old everyday multiplying that you've been doing since 6th grade with coefficients and variables. Now we got to look at the variables and think about the laws of exponents. Now, the first one I see right here is the E. What I do notice about that E is there's not an E over here. That one E on the first term is all that I have. So all I'm going to do is bring it down and hold it. So E to the 6. Now, when I get to my F, I do notice that there is an F on the first term and an F on the second term. So that means I got to put those two together, okay? So what I'm going to write right here is my F, and that's going to be 4 plus 6. Now, again, guys, I know some of you's writing is not always nice and neat and sometimes questionable. Make sure you put those exponents up in the air and it's obvious that they're exponents, okay? Now, the next thing I've noticed is I've used the E and the F on the first term, but I still have what over here? I have that G to the 3rd over there, which of course I'm just going to do what? Like I did with the E. I'm just going to bring it down and keep it. Okay, now our last step is to go ahead. Now that we've shown what we're multiplying, we're adding, and all this other stuff, we are going to write our final answer. Okay, so I've got -2 times 5 is -10. That's going to bring down the E to the 6. Now when I add my exponents on my F, that's F to the 10th. And then I've got G right here to the 3rd, okay? Now, something I have not said, if you have more than one variable, like in the last 2 examples right here, your variables are always alphabetical, okay? Now, make sure you've got these examples copied down and go ahead and make sure these are in your interactive notebook, and then you can go and work on your Canvas assignment.